Welcome. The following presentation is brought to you by Ira Einar, Harold Kwanzaa, Magnus Mackay, Tavis Young, and Francis Ian Badejo, and together we are Team ML3000. The challenge involved using a machine learning model on a list of archive projects in order to predict the outcome of future or ongoing projects so that the projects of concern can be highlighted and actions taken sooner. By doing so, this would solve the user story and address the pain point of not using historical data.
Our dataset contained all World Bank project assessments carried out by the Independent Evaluation Group since the unit's creation in the 70s. It contains more than 11,300 project assessments, of which more than 9,600 are completed. Some of the details included a geographical location, sector, the lending cost and net commitment, and the financial lending instrument. Our first task was to clean the data, so we removed columns with a high percentage of null values. After loading our data into Orange, we then selected project outcome as our target for prediction and chose specific project parameters as model features. Then we used different predictive models on a large sample from our data and tested these models on the rest of our data to figure out which model was the most accurate.
We built a predictive mining tool on Orange using our clean data set as the source, then a data sampler to split the data into trained and test data. Our data is then run through the different predictive algorithms and then tested to show which model produces the highest prediction accuracy. We reduced the number of outcomes from 62 because of the similarities between the options and to allow the model to be more focused. For both instances, when 6 or 2 options were used, random forest was found to be the most successful algorithm, giving us a predictive accuracy of 48% with 6 outcomes and 72% with the binary option of satisfactory or unsatisfactory outcome. Using a confusing matrix, we can see the ratio between the actual and predicted project outcome. This shows a prediction accuracy of 91.8% of the satisfactory and 79.3% of the unsatisfactory outcome. We also weighed the project parameters to show which were the top 5 parameters to influence the model and prediction outcome.
We've identified that there's predictive power even with the most basic project information. The parameters we've trained our model with, however, aren't time variable. To have dynamic predictions, we need a training dataset with dynamic parameters, things that indicate the health of a project and change month to month. Good examples of these include a project's cost performance index, resource capacity, and the current deviations from budget and planned hours. An algorithm trained with these parameters would allow a project manager to monitor the likelihood of project success or failure over the entire project lifecycle. We've conceptualized a Power Apps tool which would help the PM to do that. A place to input current KPIs, run the model across their portfolio, store and view the trends over time. The project manager would engage with a simple interface on their phone or laptop rather than the Orange environment. They would be able to log project KPIs at any time and see how their interventions have affected the overall chance of project success. Predicted outcomes could be collected and viewed across an office, within a region, or even nationally to help focus attention to areas of specific concern. Project managers would also be able to produce output documentation for their portfolio in a range of formats from the app, either to present updates or to forward on to their colleagues. The World Bank's project outcome ranking is a scale from highly satisfactory to highly unsatisfactory, and as the distinction between the intermediate steps is perhaps a little ambiguous, and the purpose of the prediction tool being just to indicate whether a project might be at risk and require further attention, we chose to present the output as either predicting success or failure. Reducing the model to a binary output has the dual benefit of improving predictive accuracy and making the output easier to visualize and interpret.
In order to prepare the data for the machine learning model, we identified some redundant columns with no impact on the outcome variable and removed them. Python was used to clean the data. Missing values were replaced by the mean for numerical columns, such as the lending project cost. We also ensured that the formatting of the data within the columns was consistent and that the correct data type was used. In addition to this, null values were filtered out to give more complete dataset. However, this did not significantly reduce the size of the dataset, overall resulting in better data to input into the model.
The model accuracy could be improved by collecting more data samples or using a different sample of data with more relevant parameters. We could also use cross-validation to train the model using different chunks of data and average over the result.